Hello everybody and welcome to my channel. This is the fourth video on my Swift concurrency series where I try to explain to you what's coming to Swift in terms of concurrency, because it's a huge thing with many different proposals all connected to each other, so it's a little tricky to get your head around it. We already talked about async await, also discussed actors and how that's going to impact our code bases, and we even talked about structured concurrency as a methodology, as a theory, as a way of programming that it's safer than other models. And today I want to talk about the introduction of a new set of APIs that are very important for certain aspects of concurrent programming. So let's take a look at why we need this new set of APIs. So to start, we have, as always, a demo project where I have enabled the concurrency features. Again, all of this is still in flux, and especially what I'm going to be talking today, some of it is already accepted and merged, but other parts I kind of on the air, and the specifics of it may change. So always remember that what I'm trying to give you here is an introduction to the concepts and give you the tools so you can go and explore and learn more by yourself. So to start, let's analyze what's the limitation of just having async await as a tool. Let's imagine that we want to load a file, but we want to read each line one by one. We don't want to read the entire file. And we want to read each line asynchronously to make it more performant or whatever you want. Again, this is just an example, it's not a real example, so just bear with me with the explanation. Could you imagine making an API like this, where we have a function that asynchronously gives us an object that it's going to give us the lines. And this lines object is just a sequence that we can already implement in Swift. As with any sequence implementation, we need to return an iterator, which is the one that is going to actually do the real logic and functionality. And of course, for this case, we can just fake this implementation and read the entire file and just split it and go one by one. So in a real scenario, you would want to do this more performant and with better memory consumption, but for now, let's just go with this example. And then we return the iterator, which the standard library gives us this fancy n iterator, which allows us to make an iterator just with a closure, which is very nice for these simple use cases. And then the API, it's basically letting you return for each iteration, you can return one element, and then when the sequence got into the end, you can just return nil and the iteration will finish. So that's the standard library that we have already. We have the sequence and this iterator protocol, and with this we can implement for in that lets us iterate over each line. What's the problem here? And that we don't have to be confused, because this await, it's not giving us each line asynchronously, it's getting us all the lines, all this sequence at once. So we're awaiting for getting all the lines, and then we're iterating over each line synchronously and then printing it. You see that this is not really what we want. What we want is to await for each line, so we can get each line asynchronously and concurrently. So to do this, the sequence protocol doesn't cut it. So let's switch our gears and try to implement an async lines. So let's switch gears and try to implement a way of getting each line asynchronously. As I said, the sequence doesn't cut it, so what we need to do is use this new protocol that we get, which is called Async Sequence. So we start by making a new sequence, but this time it's conforming to the Async Sequence protocol. And as with a normal sequence, we need to make an iterator, it's just that this case needs to be an async iterator. So you can see that the structure is the same. We have a struct that conforms to sequence or async sequence, and we need to make an iterator or an async iterator in this case. But the idea is the same. The difference for now is that I don't think there is a way to have like an any async iterator coming from the standard library, so you need to actually implement an iterator yourself, but that's just a minor detail. You could also do the same with the synchronous version, that's just a minor detail. And it behaves in the same way. You need to return, for every time next is called, you need to return each element, or you need to return null if the sequence has ended. And again, in this case, I'm just faking it, I'm just computing the lines beforehand, but of course this is just an example. Imagine that for each time next is called, you actually will go to the specific bytes into the hard drive to read just the line that you want or something like that, you know what I mean. The point here is that we kind of did the same thing that we have with the sequence, it's just that now the next method has an async modifier, so this next can do async work. Just with this, now we can go and instead of awaiting here, we can await on each line. So just making this change allows this for loop to actually suspend the execution of this task and actually let other things run concurrently. So we are awaiting and not blocking the main thread or anything like that on each iteration of the loop. So every time we read one of the lines. This is very powerful because it allows us to express sequences of elements that are asynchronous, which just with the simple async await, without anything on top of it, we wouldn't be able to express easily. And just to illustrate how it's actually the same as the for loop, it's just that every iteration is asynchronous, we could actually unroll this for loop and implement it manually. This is kind of like what the compiler is doing under the hood. And you could just get the async iterator yourself and then just do a while loop until you find nil. So these two things are exactly the same. Of course, we usually prefer to do a for in, but there are many occasions where when you are reading asynchronously, you may want to work yourself with iterators in order to do more complex things. But now let's have a little fun with the async sequence and explore what can we do with it. As a typical example, we can implement the naturals sequence, which is gonna just give you like all the numbers starting by 0 and going forward until infinity. So let's take a look at how we can do this. Again, it's the same thing. We just need to make an async iterator, and here the async iterator is the one that does the actual work of computing the numbers, which in this case is just incrementing it by 1. But what I'm doing here is leveraging some of the task API that we have seen in other videos to actually suspend the execution of this task and let it sleep for a bit. And I'm actually using some random times in seconds. This API is still a little bit in flux, and what I did is to make this overload here to make it a little nicer because I was tired of doing this multiplication everywhere every time I wanted to make a sleep. The other thing I'm doing is actually trying to guard against a cancellation, so I stop the infinite sequence as soon as the task is cancelled. So what can we do with this? We can iterate awaiting for each number in the sequence of natural numbers. And if we do this, we're gonna see that this is an asynchronous for loop that it's never gonna stop. And as we have the time that it's sleeping here, you see how it's printing, but not always at the same time. There is like some delay in there. But this is never gonna finish, so let's stop it for now. And just to show you that this is getting each number asynchronously, let's do something else. Let's try to do the same thing, but let's run it in an async block. So this is gonna start another child task and basically run them kind of like concurrently. So now you see that we have two prints going concurrently at the same time, and you can see that sometimes they interleave each other because I have that random sleep in there. So as you can see, this is actually giving us like async sequences, which are concurrent sequences that can suspend themselves every time you get one of the elements in the sequence, which is very powerful. The problem here now is that we have infinite sequences. Like in this case, these natural numbers is never gonna end because it's infinity. And that can happen with normal synchronous sequences. The way we try to operate with that, it's calling methods on the sequence that actually change its behavior. In this case, what I'm talking about is like we can actually prefix the sequence and say to just get the first 10 numbers. And if I run this now, it's still gonna behave as before. So every time you get a new number, it's an asynchronous operation. It can suspend itself, but when it gets to 10, it's just gonna stop. And this is just one of the many things you can do with an async sequence, because an async sequence has all the power as a normal sequence. It's just that every time you call next, that can be an asynchronous operation. That means that all the methods that we are used to when operating with sequences, you have them, pretty much all of them, available in the async world. If you want to see an example of that, like look at this. We can do a prefix here, but actually we can do a map and multiply each element by 2, and then we can even filter, for example, and say that I just want to print the numbers that are multiple of 2. And I can run this and you will see the effect that it has. So you can see how you can operate with the sequence very easily in the same way that you are used to with a synchronous sequence, but the difference is that at getting each element, it's synchronously. That's super powerful because it allows us all the composition that we are used to and all the functional operations that we are used to with an asynchronous sequence. But not only we have these ones available, we also have something that sometimes is very useful because we don't want to use for ins every time. you know that sometimes we want to use higher order functions to simplify the logic and make it easier to understand what's going on. For example, one of the most useful cases is using a reduce. So in this case, instead of using a forInt, we could just use a reduce and actually do the addition and get the total sum of these numbers. So we can get the sum here. And of course, because this is an asynchronous sequence, the compiler is telling us, yep, you need to await for this computation because it can suspend itself. So then we can just print and do the sum. And here we're working with an asynchronous sequence that it's gonna wait for all the computation to finish, add all together as it's going, and then give us the total sum. So again, we're switching from using a forInt into a reduce-like function, which is very useful in many occasions. And this shows you the power that we have when we have the concept of an asynchronous sequence with all the operations that we are used to. This concept may seem very familiar to you if you are used to working with Combine, RxSwift, and all that stuff, and I will have something to say about that in a bit. But before talking about that, let's explore another thing that is still in flux. So this part that I'm going to be talking now, it's still, I don't think it's even accepted, but it's kind of implemented, and I'm going to say that the semantics of it may change a little bit. The community is still discussing what's the best approach for that, so we will see how it ends, but I'm pretty sure that we're going to have something very similar to this at the end. So you can see that all this power comes just with this protocol, the async sequence protocol, and of course the iterator. But to make one of these sequences, you see kind of like all the boilerplate that you have to do. You could imagine that if you want to interoperate between existing code that uses other techniques like delegation or blocks, which is the same thing that we discussed when implementing async await with continuations, to go from the callback world to the async await world, it's the same situation here, but when you have these APIs that return more than once. Imagine the delegate system that calls you more than once, which is pretty common. All that stuff needs to be bridged somehow into this async sequence. You cannot bridge it directly into the async await because then you can only return one of the elements, not the entire sequence. You could do something like this for all these cases, but there are patterns that emerge that it would be nice if you don't have to repeat and actually know how to implement yourself. That's why the discussions are going into introducing some of these concepts directly on the standard library. And the concept here is an async stream. Again, the names are in flux, that's how it's called right now. So let's try, for example, to implement an async stream that gives us an element every time a timer is fired. And for that, I'm gonna start by extending the timer that we have on Foundation. And I'm just gonna make a function. I give it the time interval that I want, and it's giving me an async sequence. As you can see, I'm still returning a sequence because I don't think there is any need for anybody to know the specific implementation. I could just implement it myself. And that's what I want to make sure that you understand from this, which is this thing that I'm introducing now, it's an async stream. It's just a specific implementation of an async sequence. So we're still talking about the sequences, it's just that now we're discussing a specific implementation of it that again is still in flux. So we want to return an async stream of dates, and to implement it, it's very similar to the continuation thing that we discussed on the first video about async await. It's just that this continuation has kind of a different API because it can accept more than one value. So to start, we can use the scheduler timer API to kick off the timer. And now the interesting bit here is that we can use the continuation to yield values. So this yield is going to give a value to the async sequence and allow it to suspend. So basically with this, we're implementing this next function, but kind of like from the outside. And for the date, we can just pass this. The other thing that we have on this continuation, it's a callback for when the stream terminates. And here the idea is that we could invalidate the timer. But here we have one of these new introductions, which I haven't discussed a lot, but maybe that deserves another video, which is this whole thing about sendable types and all that thing. That's kind of another discussion. But for now, suffice to say that we can just mark this closure as sendable, and this should work. To try it, we just need to call the function that we just implemented. So we get the timer for every second, and I just prefix it with 5. So I want it to stop after 5 seconds. And then we can just do the typical await, the try, because in theory it could fail if something goes wrong, and then we just print the date. And here, just as a side note, I'm basically kickstarting the run loop so the timer works. There are other ways of doing this, but for these examples we're doing this. And as you can see, you have the timer kicking off 5 times, and then we finish here and we're done. So again, This is just a specific implementation of an async sequences. It is still in flux, but I wanted to show it to you so you understand that even if we have this async sequence protocol, in reality we expect the standard library and other libraries to implement a specific implementations of the sequences for the different use cases that we need. So don't be afraid that you have to implement the sequences and iterators manually yourself for everything that you want to do. Hopefully that's not going to be the case, because we're going to have a specific implementations for the use cases that we need. Now allow me to switch a little bit the topic and talk more about the real life implications of this, or what I do expect with this to happen. And this can be kind of like a controversial topic, so bear with me. One of the things that a lot of people kind of like freeze reaction was when everybody was talking about the introduction of async await and concurrency features into the language itself was kind of like a rejection, because we already have tools for that. People has fallen in love with things like Rx or any of the implementations like Combine or others, and it kind of has forgotten what those things were trying to solve and if they are the right tool for the job. My point is that if you look at the theory and the origins of Rx, which they were created at Microsoft, and you can see my video about actors actually talks about the same guy that created Rx back in the day. If you look at that, you're gonna learn quickly that the idea with Rx, which is kind of just the observable pattern, a little more powerful and well structured, the idea was to bring the same power that we have in the synchronous world into the asynchronous world. And one of the nice things that they explain is how on the synchronous world you have just a value, like an integer. And in the asynchronous world, you need something to handle a single value, which historically has been things like a future and or promises, all that stuff. Back then, there was nothing really that worked in the same way for the multiple values scenario, which on the synchronous world we already had solved, because you have things like sequences, arrays, lists, all that stuff is the same thing, and you can do the same things that you do with a singular value, but with multiple ones. And that guy basically created a same comparison between the synchronous world and the asynchronous world. So he introduced that last missing component, which is the observable, an Rx observable or a stream or whatever you want to call it. But basically it's the same thing that you can do in the synchronous world with an array, you could do in an asynchronous world with an observable. Now, the synchronous part is very important, but what I think actually made a huge change was the things that they took from functional programming, which is a lot of operations and higher order functions to manipulate the data as it comes, and you can do many things with that. If it sounds familiar, it's because it's literally what we have been talking about. An async sequence is nothing more than that. It's another form of the same principle of an Rx observable or any of these frameworks. So my argument is that all these people that kind of rejects all the async await features just because they are in love with Combine, which is amazing and it's a very good thing, I think they should think twice before rejecting it, Because if you think about it, in reality, 90% of the time we reach for asynchronicity is just to fetch single values, most of the time, unless you are in specific scenarios like in backend servers and things like that. For a UI application, things that come from the model and making API requests and stuff like that, usually you design them as a one-time thing, unless you build your entire system, your entire architecture with observables in mind. Furthermore, we have already seen the complexities that Rx and all these frameworks add into an application. They make things kind of harder to understand, because even if locally you can see the flow of data flowing in, extrapolating that into the entire application, And the solutions for that, it's always been, okay, jump into unidirectional architectures, make sure the flow is very encapsulated and well understood and things like that. So of course there are improvements, but I think we should, now that we were going to have new tools, kind of stop and think, do we have to reach for a big hammer when we can just do one small thing? So I guess what I'm trying to say is, if you are using things like features, I don't think you need any framework for that, just use async await. If you are using the full of Combine and Rx and all that stuff, I don't know what Apple is going to do with integrating with the APIs. I can see them making all that work with async sequences, which is going to be very nice because it's integrated. And if you think that an async sequence cannot replace fully Combine, for now I agree. I'm not saying otherwise. I just want to show you how far it gets. So I have here a SwiftUI application with a typical view model with an array of numbers that I want to start populating asynchronously. So of course, for this, you will reach into Combine and start generating things and stuff like that. But let's use the async sequence that we just created. So let's start by making an asynchronous scope here. That's what I call creating the asynchronous world. And let's mark this as a main actor. What this is going to do is ensure that anything that happens here can run on the main actor, which is where SwiftUI also runs. So I don't have to start worrying about the schedulers and dispatching things, none of that. It's just automatically done thanks to saying everything that happens here, please make sure it happens on the main actor. And the nice thing is that if here we actually called an await function that is in another actor, the system is going to handle automatically the switches between those schedulers, and we don't have to worry about that, which is super nice. So let's do what we were doing before, and then for each number, I actually want to insert it at the first index so we can see them grow from the start. And if I run this, you can see that when I click start, you start seeing all the numbers going out. Again, with the delay that we implemented before and all that stuff. That's cool. But as I showed you before, you don't have to stop there. If what you love from Combine and RX Swift and all these things is the functional aspect of it, we can filter here, and if you want, then you can map and multiply each number by 2, for example. I'm just trying to show you that the power that you have with Combine, you also have a lot of that power here. And as I showed you before, you can actually prefix this and just take the first 10, for example. And I know what you will say, yes, but Combine has a lot of operators and it's way more than that. It's actually about dealing with time and things like that. Let me show you how you can, in a simple way, again, I'm not saying this is production ready or super future proof or anything like that, but I can show you the power of it. So here what I'm doing is I'm adding a delay operator, which is gonna make a new sequence that actually delays with a sleep the execution of the next. So now you can just go here and add a delay operation here, and like the sequence is gonna start being delayed with that. So you can see how you can actually add time operators. Again, complex things like debounce and throttling and stuff like that, I'm pretty sure it could be implemented, but you probably need more work than what I just did in 5 minutes. And you don't have to stop there. Like we have things like injection of side effects in Combine or RX with like the do on next and all that stuff. You can actually implement the same thing here, you know, with just another sequence where you can hoop callbacks to actually do your work. So we can actually do here a do on next. So I'm just trying to show you how you have a lot of these tools that we think that are some way because RX can allow you to do that. I'm just telling you that, yeah, an async sequence is kind of that, you know, it's nothing that different. So you can see how we're prettying now things here. And just as a final thing, maybe you don't like the for-in, maybe this syntax feels weird if you're used to RX and Combine. You don't have to worry because you can just implement this collect, which is gonna do the for-in internally for you. And now you can just do this, and there you have it. And of course, now you need to mark this as an await, and you can see how this looks very much as what you will do with Combine and RX. Of course, the error handling is a little different because I haven't spent the time to actually make a super RX framework with these primitives. But, you know, I hope this shows you that we need to try to not reject all the new things just because we're in love with our current tools. I think the potential for the async sequence to kind of evolve and change maybe only the implementations, but actually the surface of the way we work, it's very powerful, and I think we need to see how the future evolves before trying to reject it just straight out. So that's it for this video. I tried to explain you a little bit what's coming with the async sequence API, what's the impact with that, with actually specific implementations with an async stream, which is still in flux, but you can see an example of that. And then kind of mess a little bit with the status quo, trying to tell you that, yeah, please don't reject all of this async await just from the beginning. Like, I know a lot of people is super hyped with it, which we also need to be a bit careful. Like, we don't have to switch everything in one night, but also we need to be open-minded and accept that these things may be very beneficial for all of us. If you learned something new with this video, please like it and share it with all your friends so they can learn too, and subscribe for more content like this. Thank you all for watching, and see you next time.